So let's go to example C here. I've got 1 plus cotangent y over tangent y plus 1, and I want it only in tangents. Okay. The first thing I can see here is the fact that nothing here is squared. Remember, all those identities above had to do, or I think identity 6, 7, and 8 in that list all had to do with squares, so I can't use those. The only things that are available for me to use are the facts of, like, that cotangent is cosine over sine, or tangent is sine over cosine, or the fact of the easiest way to connect cotangent with tangent is the fact that cotangent y is 1 over tangent of y, that these two functions are reciprocals of each other. So we're going to use that right there. Okay, so everywhere I see a cotangent y, I'm going to put 1 over tangent. So 1 plus 1 over tangent of y divided by tangent of y plus 1. Okay, so that makes sense to y'all about why I can't use like the cosine squareds and the sine squareds, is because those are all square things, and those formulas only work for squares. They don't work for first powers, third powers, fourth powers, any other power. That only work for squares. So if you don't have a square in there and you can't split it up into like two different squares, like we did that secant to the fourth with secant squared and secant squared, if you can't find yourself doing that, then you have to go back to one of your first original ones. All right, and then from here, technically it's all in tangent, but we've got some algebra that we can do. If I want to kind of eliminate the complex fraction in here, let's multiply the top and the bottom of this fraction by tangent of y. So if I distribute tangent of y to both the terms in here, I'll get tangent of y plus tangent of y times 1 over tangent y. Anything times its reciprocal is 1. And then down here in the denominator, I'm not going to distribute. And hopefully you see right now why I'm not going to distribute. Because top says tangent y plus 1. The bottom has a factor of tangent y plus 1. So if I cancel these guys out, what's left in the top is just 1. And what's left in the bottom is tangent y. So let's box that up and call that done. By the way, in the initial part of the problem, the reason why I didn't write cotangent in terms of like cosine over sine and then tangent as sine over cosine is because since it wanted it in tangents only, I wanted to leave this one here. I didn't want to convert them to sines and cosines since it said tangent y only. Okay, so let's go to D. A D says that we want to replace secant x and tangent x both in terms of cosine. Alright, nothing squared, so I can't use identities 6, 7, and 8. And everything's to the first power, so I'm going to actually try, I know that secant of x is 1 over cosine of x, and I know that tangent of x is sine of x over cosine of x. So let's take these two identities right there and see what we can do. So secant, I'm going to write that as 1 over cosine of x minus tangent, which is sine of x over cosine of x. Well, we have a common denominator, so we can write that top as 1 minus sine of x over cosine of x. Okay, and then from here, honestly, I just paused the thing for just a second because I was looking at this going, something's wrong. So I pulled all these problems from the book, and I just realized I actually have a typo in here. The original problem said that I need to rewrite secant x minus tangent x sine x. I'm missing that part right there. It's a big thing. So let's come up here, and so if I have an extra sine x right here, that just means right here I'm just going to put a sine x like over 1. And so we still have a common denominator. It's just going to be 1 minus sine squared right there. Big factor here that kind of helps us out a little bit. So make sure you go in your notes and you put that extra sine x right in there in the top part. So it's the problem reads as secant x minus tangent x sine x in terms of just cosine x only. Okay? Because right here I know that 1 minus sine squared x is cosine squared x. And then I just divide by my denominator. Well, I have cosine squared in the top, cosine to the first and the bottom. They cancel out, so my answer is just cosine x. I knew somewhere in here I was going to have a typo somewhere, so I finally found one. Alright, last problem for tonight is for this lesson is that we want to look at this, the fraction of 1 minus sine to the 6th over 1 minus sine squared, and we want it in terms of just cosine only. Well, the bottom doesn't look too bad. I know that 1 minus sine squared is the same thing as cosine squared. Before we get to there, let's see what we can, if there's something that we need to think about before we even cancel that off and rewrite it. Well, when I first look at this problem, I think about, wow, it would be really, really nice if I can cancel off some of this sine squared and this sine to the 6th. And then realizing the only way I can cancel is if I factor. So let me try factoring this numerator first. And the thought that popped in my head initially was the fact that I might have a difference of cubes here, where I can write as 1 minus sine to the 6y as 1 cubed minus sine squared y cubed. So remember, 2 times 3 is 6, so it's right there. So if I factor this using a difference of cubes, remember it's a short parentheses, and this is that whole SOAP thing, where it's 1, use the same sign, so minus what's being cubed for each part in the front, and then the long parentheses, where I'm going to square the first thing, opposite, the 2 multiplied together, always positive, and then the back thing squared. Okay, so let's start this problem over here, where if I factor that top, the top factors to 1 minus sine squared y times 1 plus sine squared y plus sine to the 4th y. The bottom is a sum of squares. Actually it is a difference of squares, I'm sorry, with a 1 minus, but I don't need to worry about actually factoring it because it's going to take the 2 of those away. Alright, so finishing this up with those 2 taken away, we'll give you a 1 plus sine squared y plus, and then right here instead of sine to the 4th, I'm going to write it as sine squared y times sine squared y, because I can replace each of the sine squared y's with 1 minus cosine squared y. Okay, I'm kind of running out of room here, so let me go through here and erase some of this stuff, and then we're going to come back and just finishing cleaning up, because now everything's in terms of cosine squared, and all I have to do is just clean up this right side over here, and then we can finish multiplying this out. So let's kind of come over here. So 1 plus 1 minus cosine squared y plus, and then FOIL these out. So 1 minus 2 cosine squared y plus cosine to the 4th y. Let's combine some like terms. Let's start with the cosine to the 4th y. A negative 2 cosine y and negative 1 would be negative 3 cosine squared y, and 1 plus 1 plus 1 would be plus 3. Box this up, and there we go. We have finished.